Let's hook up our momentary button. We will be connecting a 3-pin connector to it, to the S, V, and G pins. The yellow pin is our signal wire, so it's going to connect to GPIO 17. The V pin will connect to 5 volts DC. The ground pin can be connected to any of the grounds. Here I'm connecting it to physical pin number 6. As long as you have the Pi connected and powered on, you should see the illumination of the blue LED when we have the pins in the positions that we've put them there. So without pressing the button, the blue light illuminates. Just as a reminder, if we look at the schematic, we'll see that with no action from the user, the blue LED should illuminate when it's connected to power and ground. All right, let's navigate into our folder. So we're ATTC, and yours may be in your desktop and projects and stuff. All right, so I'm going to do a git pull, make sure I've got the latest part of the repository. And then the lab that we're going to be working in is lab number 6. And let's go ahead and take a look at what labs are available in there. So we're going to look at the code for each of these labs. All right, open up your editor of choice, and we're going to take a look at lab 6.1.0. So lab 6.1.0 is very similar to the last lab we ran in lab 5.1.1. The big difference here is I've changed the way that we're doing our loop here in the bottom. So this section right here is different than the way that we were doing it in lab 5. This technique is similar for either cases. It does pretty much the same thing. What it's doing here is it's determining whether or not we're running in our main program. We're starting the program, and then here in setup, it calls the setup that's found at the top of the code. So it runs this initial part, the setup, and then it is using a try. In the past, we were doing this inside of an additional while loop, but this try is saying execute this loop, and here's my loop right here, and I'm just running the loop continuously. The only scenario when I would stop the loop is when I hit an exception, the keyboard interrupt exception, and that exception calls the destroy function, and this is the destroy function where we clean up the GPIO. So not a lot different than what we ran in lab 5.1.1. Either way will work. This is going to clean things up a little bit better and help us with our future code. Other than that, it's essentially the same. We're doing the pull up resistor. 5.1.1 was a pull down resistor. And let's see, the only other thing that changed is now I'm calling the GPIO.both. Remember that this is looking for edge cases, or a scenario when my voltage changes from either low to high or high to low. In this instance, I'm looking just for any change. As soon as I detect that change, I want to call this function called button sense, and button sense calls this method or function called button sense, and it prints that the button has been pressed. All right, let's go to the terminal, and we're going to execute this code. So I'm going to use the keyword Python, and then we are executing code lab 6.1.0. When you press the button, you should see the print to terminal. It should say button pressed. Now, depending on how long you hold the button, you may get 2 print statements with just 1 button push. So we'll take a look at how we can address that next. Go ahead and pull up the code for lab 6.1.1. The only real difference here is that I've changed this to be a pull down resistor. I just wanted to demonstrate that there really is no difference between this code and the previous code when we use the command gpio.both. because all we're really looking for is a detection of the change in voltage from either high to low or low to high. So either method would work. Go back to the terminal and execute the code for 6.1.1. You'll notice that you'll see similar behavior to the previous example, but once again, the duration in which we're pressing the button can have an effect on when the message is sent that we have pressed the button. Alright, for the next section of the lab, we're going to take an LED and we're going to illuminate when we press the button. So get your dual color LED and we're going to connect the ground wire, the black wire coming out of the LED. I'm connecting it to pin 30, but you could really connect it to any ground. And then the yellow wire, which is connected to the red LED, I'm going to connect that to GPIO 18, which is physical pin number 12. Then if we take a look at the schematic of the dual color LED, you might recall that it's always provided a ground, and then when we provide power to the R pin, it would turn the red LED on, and power to the G pin would turn the green LED on. So for now we're just going to turn on the red LED. I've only slightly modified the code from 6.1.1. Let me point out some of the differences. First of all, I renamed this variable. Remember, with variables, they can be anything, right? This could say banana. So to make it a little more meaningful and understand that pin number 11 is where I have connected the signal from the button. So I've changed that to button. You may recognize or remember this from when we did the LED lab, that we indicated that pin underscore R is the variable that we're assigning to the red LED. Hopefully you recall that the LED is always grounded, and then when we provide power to pin R, we illuminate that LED. So here I'm just assigning this variable, that could be bananas once again, and I'm telling it that it's at pin number 12, and that's where we've hooked up that red wire coming out of the dual color LED. Everything this section right here is essentially the same as previously. The difference is I've added button and changed the variable name for button, and the function, I've called my function button sense, and that's just a name I've come up with. It could be banana sense, right? So a button sense. Button sense, when it detects either a change from low to high or high to low, it calls this function right here called button sense. And we had that in the previous code, button sense, and this print statement. The thing that we're adding is this. So GPIO.output and then pin R, which is number 12, and we're telling number 12 to go to a high state. If we come back up here, there's a little bit more setup that happens here. Hopefully you recall that when we needed to set up an output, we need to call GPIO.setup, and then we're saying pin R, which is number 12. We want that to be an output. And then the initial state that I want to put that pin in, and this only runs once, setup only runs once, is to turn the LED to the off position. So the LED is off. When I press the button, the LED should go to a high state. So let's see what happens when we execute this code. All right, let's go to the terminal, and we're going to run Python and then lab 6.1.2. You may receive this error that's here at the top, this runtime error. Don't worry about it. We're going to take care of it in a minute. So now when I press the button, I should see the illumination of the LED. Notice that there's no change after pressing the button. It doesn't turn it back off or anything. So one time I press it, the LED goes to a high position, but in our code we never addressed the scenario of how do we turn this LED to the off position. In the next lab, we'll look at ways to turn this LED off with the button.